For those who were in track one last time, you heard Dr. Nicole Hutchison do a little bit of an advertisement here for this talk. I'll do the full introduction. We're lucky enough to have Dr. Hutchison present along with our sponsor, Mr. Dave Pearson. So, for those who did not hear Nicole's bio earlier, Dr. Nicole Hutchison is a PI and research engineer at the CERC. Her primary work through the CERC has been in human capital development research, including the development of competency frameworks for systems engineering, such as the Helix project, digital engineering, which we'll be talking about here, and mission engineering. She's previously served on the bookcase research team, which has over 6 million views. Thank you for the correction. I knew that sounded wrong. And that work resulted in the development of the CBOC. She's currently the managing editor of the CBOC and the lead editor for the enabling systems engineering section of the CBOC. So our sponsor, Mr. Dave Pearson, is the director for Engineering and Technology Center at Defense Acquisition University. Thanks, Stephanie, appreciate that. What? Thank you. So Dave is responsible for the acquisition training of the Department of Defense's technical acquisition workforce. Mr. Pearson oversees the university's engineering, cybersecurity, software, test and evaluation, manufacturing, science and technology management, and information technology curriculums. And as we know, workforce development is a critical part of this journey. So Nicole and Dave, over to you. Thank you.
Thank you, David. Appreciate that introduction. For those of you who were here for the last talk, which is quite a few of you, I'll probably go a little more quickly through some of the background, but thank you for joining us. We're going to talk a little bit about the context for digital transformation, but then we'll turn things over to Mr. Pearson, who will talk about what's going on at DAU as they work on supporting the workforce make this transition. So I'll introduce the team really quickly. Some of them are in the room, some are not. Again, talk a little bit about context, what's going on at DAU, talk a little bit about this research task in particular, and share a couple of avenues. Like any good research task, we have a lot of different directions we're going in and exploring. So we'll share a couple of those, which are what we call case studies, which are system models that we will hopefully use for training and development, as well as digital artifacts and the work we're doing on that. So here is the research team. We have 3 universities, Stevens, Virginia Tech, and Georgia Tech, working together. As you can see, we've got quite a few people on the board, and it's been a very great team. We have a lot of fun together and occasionally try to get some work done as well. And then on the DAU side, we have the pleasure to work with Mr. Pearson, as well as Dr. Robert Reagan, Dr. Jim Roche, John Snotterly, Troy Snow, and John Quintana, who all have roles in the development of the DE and SE credentials, which Mr. Pearson will talk about in a minute. So large team of people. You get to see my face, and actually you can't see my face, so there we go. You get to see me, but obviously a lot of people and work go into this. So if you were in the last briefing, I will go through this quickly. How many people have read the DE strategy from 2018? I know you guys all have. Yep. So as you know, 5 goals associated with this strategy. One is formalizing the use of models, and that includes how do we have authoritative data. Authoritative source of truth is apparently not as vogue a term as it was, but how do we have authoritative data that we use to build models? And then how do we use these models not only across the system lifecycle, but the acquisition lifecycle, again, linking into that authoritative data. The digital engineering vision is that it will be an enabler for improving and integrating different kinds of technology, improving things like human-machine interface, taking advantage of AI and machine learning, et cetera. And then the sticky wicket of the digital engineering environment, which is actually part of what we'll be talking about here, is creating this ecosystem where you can actually do the digital engineering activities, that you have access to the data, et cetera. And central to that is the people. And the 5th goal of the strategy is that you help transform the culture and the workforce so that they can actually enable digital transformation going forward. So that's our context in a quick nutshell. And I will turn things over to Mr. Pearson.
Hey, good afternoon, everyone. Nicole, it's great to be, and a real privilege to be sharing this podium with you today. Thanks for helping the invitation to talk about this. What I'd like to do is just take a few moments to set up the problem for us and what we're trying to solve here, give you a little bit of context where we are from the sponsor's point of view. Earlier this year, right around the start of the year, the Department of Defense initiated a significant transformation in the way it categorizes and trains its technical and acquisition workforces. We consolidated many of the 14 career fields into about 6 career fields, came up with a new career field for the technical disciplines where we combined the traditional engineering, science and technology management, production and quality management, and software acquisition career fields or functional areas into a single one, called the Engineering and Technical Management career field. And with that new career field came a whole bunch of new competencies designed for just this workforce. And in addition to that, once you get new competencies, it requires DAU to build out a whole new curriculum based upon those competencies to train this workforce up on the skills that they think they're going to be needing to do their job successfully in the workplace. The second key change about that transformation was in the training approach. If you recall, perhaps if you went through any of our training that supported previous qualifications, we had a three level certification program, which took you up to about the 10-year career point within it for an acquisition professional. And it was very comprehensive and very deep. Our courses typically ran 1 to 2 weeks long, and you'd be coming back with them over the course of your career, principally until you got certified at about the 8 to 10 career year point. The second piece of that transformation was to change that training paradigm, where we just came up with the certification training requirements that everybody has to take, and it was really much thinner, just applied to that basic core competencies that everybody in that workforce needed to have. So it was much shallower, much general. And that's what we've got now, a certification curriculum, which is much narrower and shorter than it was in the past. But then we amplified that core mandatory training with a credentialing approach, where we created optional training tracks, deeper diving credentials on narrower topics, which went deeper in a particular topic and placed greater emphasis on narrower job-specific skills that the employee can take back to the workplace with them. Very, very big change for us, and a whole new curriculum got developed. We were given at DAU a series of competency areas to build out those credentialing areas, to amplify and supplement that core training. And we came up with a structure which I've presented here on the slide. So those basic certification courses, there are 18 of them altogether, 9 at the first level, and then 9 additional ones at the more advanced practitioner level. And each one of those courses is focused on a particular topic, one of those key competencies that we talked about earlier. And one of those competencies is digital literacy. We wanted every member of the technical workforce in DoD who works in acquisition to have a basic digital literacy that they could take and carry on. And we built a series of courses to support that. The first one is just a simple 4-hour course at level 1, what we call the foundational level. And then there was an advanced course offered at the practitioner level on the same topic of digital literacy. And that's the training everybody is required to take within the technical area. But we took that further, and we're also given, excuse me, a series of credentials that we had to build out. And there are 8 what they called credentialing areas, 8 credentialing areas that span everything from traditional systems engineering, manufacturing engineering, software engineering, quality assurance, mission engineering, science and technology management, and it included digital engineering. And what we're doing right now with the CERC's help is building out this curriculum of digital engineering credentials. There are 2 of them projected to be built. We're building the first one right now. And this digital engineering credential is being taught at the intermediate level, taking off from that basic training that everybody got earlier, going much deeper and much more specific into the digital engineering tools that people use. There are going to be 6 courses in this credential, about 50 hours of training altogether. And we're also going to be complementing that training track with a laboratory immersive experience where students are going to have the opportunity to go into a playground and work on Cameo and start actually working on some of these tools. Again, hands-on applications of this area. So I've been working with the CERC to do that. But I'll tell you, as I built out and started investigating this credential and some of the other credentials that are needed in some of the adjacent areas, we quickly realized that digital engineering isn't just about digital engineering, but it's the application of it across a whole bunch of adjacent disciplines. We learned in designing the other credentials that you really can't do mission engineering without first knowing some digital engineering. You can't really do system security engineering without having a basic knowledge of digital engineering. And of course, the systems engineering discipline is increasingly being dependent upon digital engineering to do it. So what we recognized is that we had to spread this knowledge across additional disciplines and provide that information and that training across the other credentials that we are building out in support of this new paradigm. But in addition to that, the more we thought about it and read a couple of times the systems engineering strategy, or I'm sorry, the digital engineering strategy, we recognized that even that expansion was insufficient. Because as we look ahead to where the department is going, regardless of what acquisition discipline you're in, whether it be contracting or test and evaluation or logistics, the way things are going to be done in the future, all of those disciplines will be increasingly relying upon digital artifacts and models to help support their decision-making as we try to move away from the static PowerPoint slides and Excel spreadsheets to make some of these critical decisions. So when we started thinking about all this, we're recognizing that nearly all members of the acquisition workforce are going to need some type of knowledge, working knowledge of digital engineering and using models to support their decision-making. And again, with the help of the CERC, we're thinking our way through that. If I could see the next slide, please. I'll just advance this, or you can advance. There we go. So in support of that, we have this concept, this vision that we want to build a digital training ecosystem to support not only digital engineering training, and not only the other technical disciplines such as cyber resilient systems engineering, such as cyber resilient engineering and mission engineering, but eventually we want to provide a common set of models and tools and digital artifacts that can use across all of the training that we do, across all acquisition disciplines, across the entire product lifecycle. And that's the help that we're getting from the CERC and supporting, building out and informing us on what this digital ecosystem should look like, and making sure we help us build out the courses that are needed to support it. So that's the context of the problem. Happy to talk with you a little bit about it later if you'd like, or go into some more details. But Nicole, if you want to go ahead and summarize the work that you're doing, I'd sure appreciate it. Thanks.
Thank you, Mr. Pearson. And I just want to reiterate, I'm very impressed that DAU is really taking on this sea change. You know, as Mr. Pearson said, moving from the traditional 3-level certification approach to this pared down certification with a number of different credentials is a major change in the way DAU has been doing business. And excited to get to work with you all on that, but also just want to highlight that that is a lot of work and effort going into changing that approach. So really quickly, I'm going to throw these 2 terms out and they'll pop up here and there. When we talk about digital transformation, we're really talking about 2 different things. One is digitization. And again, if I have a requirements document and now I have a requirements PDF, yay, I have a digital document. But it's not digitalized, which means that we've actually changed the way that we do the work, changed the way that we capture requirements so that we take advantage of that the power of using digital environment and digital tools. So it's those two things together that really lead to digital transformation. Ideally, we'll eventually digitalize everything, but the truth of the matter is, as people and particularly existing programs are trying to figure out how we implement this, that first step of digitization is actually not always easy. And you'll see we've got a couple of examples of that, of just trying to take, for example, the systems engineering plan. What does the existing document standard look like? How can we capture that information from a model is not necessarily straightforward. So even tackling some of those things to give stakeholders artifacts that they're used to seeing is part of the challenge as well. How many people have seen the wall chart? Yes, we all know and love the wall chart. The major point of the context here is that all of these boxes are important. There's data that underlies all of these boxes. But it's also, this is hard to get your head around, right? So part of the power of digital engineering is no matter where within this whole life cycle you fit, digital engineering should simplify this view so that if you need to get to this level of detail, you can, but it's going to help us as a community be able to have a much clearer and simpler systemic understanding and systematic understanding of what we're doing. So we all know within the last few years, we have the adaptive acquisition framework. And so that is a good step in how do we apply these approaches and principles of acquisition a little bit differently depending on what it is we're trying to do. So that's a good step and a good evolution of what we're doing, but it doesn't, again, take us all the way as far as we need to. This is more of an art chart than I thought, so I'm sorry about that. But what we had a graduate student do is they actually went through all of the existing acquisition documents and built this systemogram that said, okay, let's take it all the way from the threat or the issue that we need to address, and how does that flow through the system at the simplest, highest level to get us through to a military capability. And so, again, this is the type of graphic that we like to come back to because it simplifies this a little bit to help people understand where they fit within this without having to go through the level of complexity that you see, for example, in the wall chart. All right, so that's just more context. Simulation training environment for digital engineering, because if you're going to do something in the DoD, you need a good acronym. So we chose STEDE, and actually I'm going to say David came up with STEDE. So this is what we're trying to do to support DAU, and it's an environment that utilizes tools, and right now we're focused on Cameo. I know you're going to ask because everybody wants to know what tool you're using. What we're trying to do is use the tool because we need to pick one, but do our learning and training in an agnostic way. So it's really focused on principles. You just happen to be using Cameo rather than we're teaching you how to use Cameo. So within STEDE, we have a couple of different things. We have the case studies that I mentioned earlier, and we'll talk about a couple of those. These are complex, realistic, but fictitious systems that will help people get a real sense, hands-on, what it is like to work in these models as part of their training environment. So I'm sure we've all done death by PowerPoint. We've all seen the SysML diagram, and I'm sorry, I have some too, that are on a PowerPoint chart, and they're just unreadable. So this is the idea, is that taking it further so that students, as Mr. Pearson said, actually are going to go in and work with the models, and part of their training is, we've talked about this in principle, now let's actually go do it. Really increasing the value to the students and to the organization so that when they finish this training, they have more skills that they can directly apply on the job. So those are case studies. We have what we call the DE textbook. I will buy a drink to anyone who comes up with a better phrase. We call it the DE textbook because we're not sure what else to call it. But the idea is that this is modularized around particular topics and will help people understand kind of basic principles. We'll point them to templates. We'll point them around. If you're familiar with the systems engineering body of knowledge, that's a fairly good analog. So we're calling it the DE textbook because we want it to be sort of foundational, and that anyone, not just DAU, can pull and use this information in courses or training. If you've got a better name than textbook, let me know. And then we have exercises, which are the mapping between the two, the mapping between the topics that are critical for training in digital engineering and those case studies. So that's the pathway that we use to help the students progress. As part of this, we also have models of the acquisition lifecycle itself, as well as some of the model management things. And if you listen to any of Dr. Blackburn's talks earlier today, he talked about things like branching and trunking and digital sign-off and how you actually manage the data in the environment. And so understanding that as part of this overall picture is part of what we're trying to build. So that's what we're trying to build in STEDE. And then again, what we're hoping is that those can be used for learning assets. You can use the materials, copy and paste them. Hopefully they'll be incorporated into the DAU curriculum as well. And so it just becomes a real resource to the community on ways to get this kind of information. If you were here for the digital engineering competency framework discussion, you've heard a little about it. If not, the CERC has generated a competency framework specifically around digital engineering, and that is also part of this ecosystem. So while we're tracking things like learning objectives for the DAU courses and topics, we're also working to tie it all back to that standard framework so that we can always say, okay, if you need to understand this competency area, here are the things that relate to that. So that's the big picture. We did a talk on the digital engineering competency framework. I'm not going to go into a whole lot of detail on this. The talks are recorded, so if you missed that and you want to watch it, you can. Main thing being that there are 5 areas. The data engineering, so the foundational data, how do you use data and manage it and deal with it appropriately? How do you use that data for modeling and simulation? And within the framework, that includes things like data analytics and AI. The models and simulations then support the actual kind of official digital engineering and analysis activities, which are a combination of systems engineering and engineering management, again, done in this digital environment. System software, as capabilities are increasingly delivered through software, it's just critically important that everyone have some basic understanding of how software is put together and what the core principles of software engineering are. It doesn't mean everyone needs to be able to write a script, because that's not a skill I have, but that you have some awareness of that, and also how all of that software that you put together in your environment and ecosystem comes together. And then finally, there's the digital enterprise environment itself, and that's how do you build it, manage, and maintain it. And so the idea here is not that everybody needs to be an expert in all of these fields, because that would be completely ridiculous, but we will have people in different parts of the department who will need to be skilled in certain areas. So as Mr. Pearson said, there's a course now on digital literacy, and that is the kind of thing that everyone needs. Some people will also need to understand data governance and management at a more detailed level, some will not. And so this is intended to be a very holistic framework that allows for tailoring based on role. Okay, so again, I said the digital textbook in quotes because this is not the right framework, but the idea is that eventually when this exists, any student, if you have a question, you can go to the textbook, you can look through the modules, you can explore your topics, and my animations went the wrong way. I hate when that happens. You can actually do some exercises and projects within that environment. So I need to understand a little bit more about how I do, requirements traceability in models versus, doing things in my Excel spreadsheet, which some of us are still using. Actually pulling up some templates. Okay, this makes sense, but I'm not sure how to do this from scratch. We'll have templates available that you can actually incorporate into your environment. And so this is kind of a different path in to say, I don't know that DAU courses exist or these credentials, credentials exist. This would also then point you to say, if you need to learn more about this, here are the resources that are available to you. So it's intended to be, again, kind of a one-stop shop. And this is just notional, but basically, again, we want to have this modularized in a way that it can be reused as appropriate. So if the services are putting something together, if DAU needs to put together another course, or if a university does, these resources are out there and available. And again, the exercises are the link between the textbook and the case studies. So this is a very notional example. These things are all connected because we see these as kind of the main thematic areas. So what, foundationally, what are digital engineering and systems engineering? What's the relationship? What's digital transformation? What are models, et cetera? And then within each node, then we would continue to branch out and build down to the modular level again so that we can improve reuse and availability. Maybe. Okay, I told you I would show you some beautiful diagrams, so here we are. One of the things that we've tried to do is practice what we preach, and so we have actually modeled excuse me, the STEDE environment and modeled not only the learning system, but the textbook. And we've tried to do all of the good work of actually following the practices of digital approaches. So you can see here, this is our context. It shows kind of the different classes of users from students to content developers, et cetera. This is from a Jupyter notebook that some of the team have put together. And what this does is actually pulls from live models in just a very simple web-based thing. So you can have information and then you can say, okay, in the existing model, here's the data. What happens if you change this parameter? And you can have some light interaction in a web-based way. So this context starts with our DE meta model, which is basically what are the kinds of things that you're going to include in your digital engineering environment. And these words should not be surprising to you: components, requirements, how all of those things link and fit together. Excuse me. You can see at the top, you see DE SCREE, DTE. What these are is basically extensions. So if everything starts from a foundation of digital engineering, then how can we build off that foundation to support other areas? And so these are just some examples of that. So secure cyber resilient engineering is, again, one of the areas that we're working on. You can see, again, some of the process extensions on the right. So things like the NavSem, that is actually a model. So that's a model that we have incorporated into this environment so that you can use that as foundation as well as a template for the work. And then we have within our environment, again, a number of reports that you can run so that you can pull information out in a way that's palatable to decision makers rather than just to people who are used to working in kind of a Cameo environment. All right, so quickly to talk about a couple of the case studies. How many have heard of Skyzer? I know a lot of you have. So Mark Blackburn, Dr. Mark Blackburn has led this work, started with NavAir. He's now done work with Army and now working to extend this with Space Force. And basically what it is again, a fictitious, it's not a real system, UAV, but it uses realistic data. And the Con-OPS is that this is for search and rescue. So it's got to be able to go out, land on a ship, have a number of parameters. And this is a full stack model. So it starts with the system model, or excuse me, the mission model. It includes system models, system architectures, physics-based models, et cetera. And then we have a number of digital threads that run through it so that we can then have, again, students practice things that they might do, for example, digital sign-off. So if I need to sign off that this model is appropriately mature, we're ready to move on to the next phase, how do I actually do that? There's an exercise around trade-offs. So I won't get into the details, but there's a trade-off between kind of landing speed and max speed, and the students can actually walk through that and see, wait, I have conflicting requirements. Now that I've discovered that I have two requirements that I can't satisfy at the same time, how do we make the decision about what we actually need to do? So Silverfish is another one. It is a UAV that is essentially monitoring kind of a minefield and trying to secure that as appropriate. This one is really built for purpose for cyber resilience. And so it's heavily focused on how do you engineer resilience in from the very beginning. So it's I wish Peter were in the room because I would point to him, but he has some really interesting concepts about how you conceptualize resilience even before you have an architecture. So before you have requirements or anything like that, how do you think about resilience in a useful way? And again, this is one of the examples that is currently being built into the Secure Cyber Resilience credential. Acquisition lifecycle, we'll talk a little bit for a second about the artifacts. Thank you. So we talked about digitalization, right? So the first thing we said is, okay, if we take one of these case studies that we have and we said, okay, we need to make a digital systems engineering plan. We took SEP version 4 template and said, okay, here's what data is required in the document, what information we need. What models do we have that provide some of that information? And what you see here, and I apologize, the lines ended up a little too light when I put this in the PowerPoint template. But what you see is that there are a lot of different models required to satisfy a number of those data points. There's data that is in the SEP that we don't currently have in our models. And that's what I was talking about earlier. When you talk about digitization, even that is not necessarily a simple thing. All we're trying to do is essentially have a report that replicates what the systems engineering plan would look like. And as you can see, it requires data calls from a lot of different places, and we still have gaps that we are going to have to add to our models in order to address. And this is essentially the same information, just again, showing you that we're eating our own cooking. This is the actual view in Cameo of what the alignment is between those things. So we're working through that and working through getting the template for the digital SEP. And then the idea is to move from the digitized version to then how do we digitalize it that we make that you can meet the intent of a systems engineering plan, but not actually necessarily have to use the same format. And then another example is the digital temp, test and evaluation plan. So again, we have a number of examples like this. The hope is that we will build robust exercises around these that will help students understand what this whole digital transformation thing means to them. And am I out? Okay. And I think that's where we'll stop. So happy to take any questions.
Thanks, Nicole.
So questions for Dr. Hutchison and Mr. Pearson?
Of course.
Yes.
Complete opposite end of the room.
We like suggestions. So, yeah. So the people online can hear you.
Oh, okay. The suggestion was the Digital Engineering Almanac as your title.
Like that.
Textbook.
I
Either
like
that
that
or
a lot.
compendium. That was another word I was thinking.
I like almanac. Okay, I might owe you a drink.
And offer the rationale again, because I think the rationale was key.
Yeah.
The rationale for it?
Yeah.
Oh, well, the almanac would be if you were like republishing it every year, right?
Yeah.
You're updating it.
Yep.
Yeah.
Absolutely. I like that. I think I'll buy you a free drink at the reception. Thank you. Appreciate that.
So some of the SEP is covered by models, some of it is not. Is there a follow-on effort to see if you can replicate the SEP in models, or are you taking this further?
So we are, it's initially planned as a 3-year task, and we're right at the halfway point. So we're halfway through year 2. So there's a considerable amount of work left to be done. This is just where we are at the moment. So yeah, the plan is that we will do things like add to the models, make them more robust. Right now we have 3 case studies. I didn't mention the third one, which is called Firebird. It's an AFIT case study. But we also have another one that we're looking at designing from scratch. So this is where we are, but we certainly plan to add to. The exciting thing about Bulldog, which is the one we'd like to build, it's based on the exercises they actually already do in the systems engineering curriculum. And it goes all the way through the design process and currently instantiated, they actually, build the Lego robots and do things with it. So it really helps people go through and visualize, and it's a little more hands-on. And we can build that for purpose to really address this. Right now, we're reusing things that weren't designed specifically for instruction. So the hope is that we will be able to deliver that as well.
You mentioned using Cameo as the MBSE tool. Is there a digital engineering platform, like an IOIF or a Teamwork Cloud type of functionality in the set that you're using to do the digital thread type?
Yeah, so a couple of things. One is with Skyzer, we do use Teamwork Cloud, and that gives that decision maker view that's just web-based. You don't have to actually look at the Cameo models. Again, some people break out in a sweat if you ask them to do that. So we can give a much more simplified view of that. Right now, Silverfish does not. Silverfish was actually created in Genesis, so we're working on converting it to Cameo and learning a lot actually about if you have all of this built in one tool, even though the principles are the same, what are the things that have to change as you move through? So also capturing those kinds of lessons learned as we move through.
Nicole, I just, just what you just said, did you mean Teamwork Cloud or Cameo Collaborator? Because you said they didn't need
Teamwork Cloud is what we're using.
Yeah, Teamwork Cloud,
Yeah.
They do have to get into the model. I thought, okay. I just got confused.
We can talk through it. So it's the MBE view editor that's paired with Teamwork Cloud. Because we can't have one tool that does everything. That would be crazy.
All right. So I'm used to telling people, you can use Cameo Collaborator if you don't want to actually get all the way into the model. So you were talking about something different.
Yeah, we can talk offline. I'll happy to walk through that. No, that's a good point. Thank you.
So as kind of the out question, either for yourself or for Ms. Pearson, the credential has 6 courses, so that we have a good scope on that. Can you list what the 6 courses are?
I can. Would you like to go first?
Oh, I've got them ahead.
It was not meant as a test.
Yeah.
So the course one is using SysML. The second one is MBSE. The third one is digital engineering environment. The fourth course is digital engineering technical processes. Then there's digital engineering acquisition management processes. And then finally, there's a capstone to stitch it all together. And that's the 6 courses. And then again, there's going to be a 7th course that's really not part of the credential, but a kind of a laboratory which allows the students to explore and learn with Cameo. And they'll put it all together. And that is the first of 2 credentials.
Right.
And we'll see where the second credential takes us as we flesh this out and see where this first one goes.
Excellent.
Very good. Thank you both.
Sure,
Thank you
thanks.
all.